Hello, everyone, and welcome to today's Tech Excellence session. As you already may know, our vision is to raise the bar of technical excellence across the world. Who are we? Valentina. Valentina, she's founder and organizer at Tech Excellence. Daniel, Oliver, and myself, we are organizers, co-organizers, and co-hosts. We had a lot of great speakers this year, and we continue having amazing speakers this year, so stay with us. You can follow us on different social media platforms such as Meetup, YouTube, LinkedIn, Twitter, GitHub, and Discord. Our sponsor is Optimum, and our partner is QE Unit. So today, today we are very happy to introduce Nicholas Ocket. Nicholas, he's a software engineer with a passion for software design. He teaches software design with his platform about coding. I'm actually very interested about this one, so we'll hear about this one later. The title of his session today is Effective Software Design Going Forward by Taking a Step Back. But before I hand over to him, I would like to remind you, you can leave your comments and questions anytime in the chat below. At the end of our session, we'll have a 30 minutes time slot for it. So Nicholas, enjoy your presentation.
All right, all right. Hey, everybody, welcome to my talk, Effective Software Design, going forward by taking a step back. So maybe a little bit about myself before we really start. Who am I? My name is Nicolas Ocket. I am a senior software developer / engineer. I have about 15 years of experience in multiple domains. Now, I am very passionate about software design, which is why I started my platform About Coding. The mission of About Coding is to teach people proper and effective software design. It's a work in progress, but be sure to check it out. There's great stuff on there already. I'm also quite active on LinkedIn, where I share insights and tips, and I also have a monthly newsletter. And my newsletters, they are hosted on Medium, so that could also be very interesting, right? So what am I going to talk about this evening? I am going to talk about a problem with software design. And I see it more and more these days. After that, we will shortly discuss some misconceptions and myths concerning software design. I will go over what it means to be effective. And then we will discuss the goal of software design, context, change, evolution, and complexity. And I'll finish by quickly going over some core concepts. All right, for the record, this is not a picture of me, right? I mean, with all the muscles, you might mistaken it for me, but this is not me, this is Bruce Lee, right? And Bruce Lee was a famous martial artist and actor. And Bruce Lee allegedly once said, "I fear not the man who has practiced 10,000 kicks once, but I fear the man who has practiced one kick 10,000 times." I like this quote a lot. And I wonder, what if Bruce Lee was a software developer today? What if he was a software engineer? Then I think he might have said something. "I fear the code of the developer who has practiced 10,000 principles and design patterns only once." Yeah, exactly. So software designed today in our industry, I see a lot more developers who have practiced 10,000 principles only once and not the other way around. And I get it, really. There's no shame in it. And I do not intend to finger point, right? But I do want to point it out because I get it. Today, everything needs to go fast. Everybody wants to be the Kung Fu master. Everybody wants to know all of the secrets as fast as possible. It looks like there's no more room anymore to put time and effort into something. Fast solutions, no effort. That's what today is all about. If there's a shortcut, we will take it. It seems like we mindlessly absorb whatever people feed us and accept it as true without trying to understand. So, as an industry, do we, software developers and engineers and architects, do we want to be valued by the amount of different software design principles and buzzwords that we can recite? No, we don't. We are problem solvers, right? But this kind of thinking, it leads to misconceptions and misunderstandings. It leads to people who forget what is really important. And so what happens is they have pointless discussions on which solution is cleaner or more DDD. And they take meaningless decisions because they don't really understand why they should or why they should not use principle X or pattern Y. And so in the end, this leads to ineffective software design. And here are a few misconceptions that I want to talk about, right? And the first misconception is about solid. The misconception is that if you don't know solid, you don't know software design, as if solid is what software design is all about. Now, I think this is because these principles, they are quite famous and they have been well marketed. And so what happens is that people quickly look into solid and they say, oh, it's only 5 principles. That isn't so bad. And then they look at the principles and then they say, these aren't so complex to learn. It's going to be easy. And so they learn to recite these principles, but they don't make the effort to really understand them. The thing is, you don't need solid to be effective in software design. Now, I know people who don't have a clue about solid, but they can write decent and maintainable code. Unfortunately, I also know a lot more people who do know about solid, and well, this happens. And they say, hey, I know solid. And then I say, okay, show me. And then they slap you with spaghetti code nonetheless. So, are solid principles worthless? Should you not take time and effort to learn them? That is not what I'm saying, right? I am saying that you don't need them to be effective, but it's good to have them in your toolbox. There's just more to them principles than just being able to recite them. Now, the next misconception is also something I see a lot. It's about reusability. When I talk to junior developers or people who are getting into software development, this is something that they hear a lot. The idea that lives that you need to design for reusability because you will win time. Please don't design specifically for reusability. You don't need this to be effective in software design. During my career, I have often seen people trying to isolate pieces of code and put them in separate functions or classes because they might be reused. And people do it because in a not so certain future, they might save a little bit of time. The reality is that the code that you are writing will most likely not be reused outside of your problem domain, unless, of course, you are designing a framework or a library, right? Often, these pieces of code actually only have meaning in the context of what stakeholders want. And once you pull out the code out of its problem context, it just becomes hard to use it anywhere else. And what happens is this: the piece of code that is supposed to be reusable actually doesn't entirely fit the new context. So it needs to change just a little bit. But by changing it, you already risk writing bugs and unwanted side effects. You set yourself up to lose exponentially more time than you would have ever won with reuse. Does this mean that reusability sucks? That it is not important and not worth investing in? Again, that's not what I'm saying. Reusability can be very useful and helpful, and it is good to have it in your toolbox. But I'm saying that designing specifically for reusability will not make you effective in software design. Now, the last misconception, I have to warn you, the last misconception is about TDD and it might be shocking, right? The idea with TDD is that it will automatically lead to a good design. If you practice TDD, the best possible design is going to emerge no matter what. That is just not true. Well, at least not always. You don't need TDD to be effective in software design. Oh my God. He said, what about TDD? Yeah, I'm sorry, people, but bear with me, I'll explain. If you don't know what good design is, TDD will not help you. And I know this from personal experience. Now, TDD, I'm taking a shortcut here, but TDD is a methodology, right? It's a way of writing code which, at the very least, will result in tested code. But that doesn't mean that it will result in a good design, especially not when you are just starting in software development. So especially not when you're a junior, right? So I guess that the confusion comes from the fact that good design means that code can be easily tested. And that's true. However, not all tested code is well designed. And in order to know the difference, you need to know what is important for good design. Am I saying that TDD sucks and that you shouldn't learn it? Not at all. On the contrary, even. Will TDD help you to write more robust code? Yes, for sure. Is it possible that TDD will help you to fine-tune your design? Absolutely. I'm saying that TDD should be in your toolbox. It's just you don't need it to be effective in software design. All right? So I think that we are missing the point. There are a lot of misconceptions out there, and honestly, I can fill hours just discussing these. But we seem to be missing the point. It seems like we believe that we need these mysterious principles and these techniques and whatnot in order to be good at software design. And the best analogy that I can come up with is that these techniques and patterns are like crutches for people who want to walk. However, in this analogy, these people just don't really know what walking is. We seem to have forgotten what software design is and how we best use it. So I think in order to be able to go forward, we need to take a step back. We need to go back to basics and to common sense. We need to blow away some of the hot air in software design and just look back at what is really important. So let's start at the start. What does it mean to be effective? Being effective means that you are successful in producing a desired or intended result. It means doing something that brings you closer to an intended goal. And it also implies, by the way, that you can check if your actions got you any closer to that intended result. Now, if we put that in the context of software design, what does it mean to be effective in software design? Well, it means that you know why you take decisions and which decisions are going to take you closer to a better software design. You can't make effective decisions if you don't really know what the goal is that you're aiming at. You cannot be effective if you don't know why you are doing what you're doing. And there are so many developers out there who don't know. I believe in general, we lack the why, and thus we are not able to assess our decisions or if our decisions got us any closer to our intended outcome. If you ask developers, like, why did you implement a certain design pattern? Usually the real reason will be because they can. They saw an opportunity for the pattern, and you can't do anything wrong with a design pattern, right? So they just implemented it. But did it really improve the code? Does the change have any impact on the desired outcome? Who knows? Okay, so here we are. What do we need to be effective in software design? which techniques and principles and patterns are the most effective. This is interesting, right? I'm sorry, but I will have to disappoint you. No techniques yet, no principles, nor design patterns yet. Whoa. Seriously, then what do we need? Well, we just need to go back to basics. First and foremost, I think we need to know what software design is and what we're trying to do with it, what we're trying to get out from it. What is the goal of software design? We need to know this because you can't be effective if you don't know what you're actually doing. Okay, so what is software design? On one side, software design is a process. Yes, indeed, it's a process. It's not a single moment in time where everybody sits together to draw some boxes on a whiteboard and then be done with it. No, it's an ongoing process. And in this ongoing process, we continuously think about ways to structure and shape our code solutions in such a way that future maintenance costs are kept as low as possible. That's the goal. And how do we do that? We do that by enabling change in the solution every single time that we touch the code. On the other hand, software design is a toolbox. It's a toolbox filled with best practices, principles, and techniques which can be used to enable change in code. And these practices and these techniques, they have emerged from the experience of people who were coding long before we did. I'm talking about Uncle Bob, I'm talking about Bernard Meyer, all of the famous people that you probably read about. They faced the same problems as we do today. And through failure and experience, insights and techniques followed. That is, in short, what software design really is. The next thing that we need to be effective in software design is to understand. We lack understanding of even the most basic concepts in software design. And I'm not only talking about the vast amount of junior developers in the industry. They are growing, and that's a good thing, really, it's a good thing. But somewhere along the way, a lot of senior developers don't seem to understand either or no longer. So what do we need to understand? First, I think we need to understand what it means to enable change. To me, it's simple. Enabling change means that any developer can relatively quickly find where changes need to happen. And the changes are isolated. The changes in the code have a low chance of breaking the code or triggering any unwanted side effects. And an example of unwanted side effects is like the ripple effect, where you change one class or one function, and because of that, you have to change 3 others, and then some more and some more. And so your change just ripples throughout your code base. We should be able to somewhat predict which code parts are going to need changes. And that's it. That's what enabling change means. No more, no less. And again, it doesn't mean that you design your application only once and that you're done with it forever and ever. And any future change should be, with unmatched elegance and galactic beauty and whatnot. No, it's a process. And with every change that you make in the code, you need to make sure that the code still enables change. That's the point. So what's the hands-on goal of software design, right? How do we do this? What do we do to keep maintenance costs low? Well, we structure our code in isolated, independent modules, which each play their part in the application. Because each module has a particular role, a particular function, and because these modules are isolated, as far as they can be totally isolated, right? Change will not spread uncontrollably. And that way we can keep the maintenance costs as low as we can. And let's not lie to ourselves either here. I will stress that, costs for maintenance in an application, there will still be costs and there will still be high because change will still spread. And it will, because you cannot have software modules that are completely isolated. In some way, we build different components that are working together, and thus they are depending on each other. We don't want only one class or one big function of 40,000 lines of code. No, we want components that are working together, right? So it's inevitable that change will spread. But, we try to keep it contained as much as we can. I get the question a lot from people, and they ask, what's the most effective way to structure the code and to isolate change? It's a good question, but the answer might probably shock you. There is no best way. There is no best way because how you should be structuring your code, it depends on the domain that you're working in and the stakeholders that are interested in the solution. And this brings me to the next thing that we need to understand. That's context. What is context? Now, imagine a certain situation, and context is just circumstances that add up to the situation. And by doing so, they give extra meaning to the situation. Context is the sum of circumstances which help define a certain setting or a certain situation. Context can help to explain why a situation is what it is. It offers a different perspective. Everything is context in software design, and we tend to forget that. So, what is context in software design specifically? What are those circumstances? What are those factors that we keep on forgetting? First, and I already mentioned it, it's the specific domain that you're working in. The domain that you are currently working in is a big part of your current context. Small example, if you're working in hospitality, an order is not the same as an e-commerce order, right? An order in hospitality in a restaurant, it's not the same as an e-commerce order. Sure, you can abstract the concept of an order and you can have one size fits all model. What's the point in that? You will not be able to reuse it anyway. And then the second part that builds or that makes the context of what you're working in, those are your stakeholders. And they are a critical part of the context. Now, stakeholders, what specifically makes the context? Which specific parts of your stakeholders make the context? Well, it's their needs and their requirements, specific needs and specific requirements from specific groups of stakeholders. It's what they want, right? And there could also be, or the other part that makes up your context, that's, for example, a budget that you get from your managers or your stakeholders. That could be either time or money. Here is how context works in software design. So our hands-on goal is to enable change in our code. We want to make sure that our code is tested, that it can be tested, that it's understandable, etc. How do we do that? We do that by applying software design principles and techniques and so on. At some point, however, your stakeholders are going to need something or want something, and this is going to collide with your software design goal. Or at some other point in time, the costs of a solution are going to collide with your software design goal. Or maybe at some point, specific traits of the domain will need some attention and they will collide with your software design goal. And those points where context crosses your goals of software design, that is where trade-offs are born, right? And so, you know what? Trade-offs are going to force you to break the rules of software design. They are going to force you to break your clean architecture or your hexagonal architecture. And that's okay, because software design and their principles and whatnot, they are like the pirate code. These design principles are more like what you call guidelines and than actual rules. So don't be a fanatic. Don't hold too tight to these principles. Context is crucial if you want to end up with a good solution. Next up is change. Change is important in software design. I guess that we all know that. The entire reason of the existence of software design is about change. But we don't seem to understand change that well, or at least not in the context of software design. We don't know when change will come, and we don't know in what form. I would even go as far and say that we as software developers, we sometimes seem to be a bit afraid of change. The general notion of change with software developers is that, change is bad. We don't want change. That's not entirely true, is it? In our designs, we are trying to make change as easy as possible. And that's great, but it's not easy to do. And I find it curious that we are doing software design to enable change, to make sure that change is relatively easy in our code. But if we don't understand change, if we don't understand what the reasons are for change or where change is coming from, then how are we going to effectively enable change in our code? How can you then take action and assess the effectiveness? Now, there's no way that we can predict the future. Nothing will show us in detail which changes are about to come or what exactly will change. And let's be honest, artificial intelligence, it's not that good at predicting the future yet. So are we then completely lost when it comes to change? No, we're not completely lost because we know where most changes will come from. Most of the changes that we do come from our stakeholders. And I say most changes, not all changes. Now, how come this is true? We write software solutions to fulfill the needs of our stakeholders. We figure out what they want, we figure out how they want it, and these are basically our use cases. Now let's think. If our stakeholders, if they want something else, or if their needs and requirements change, then the use cases will change. And thus your code will change. And that's why our stakeholders are the reasons for change. Now, I know we still don't know in detail what will change. It won't tell us when change will come. However, I think that those are the wrong questions to ask. In my opinion and in my experience, it's not that important to know in detail what will change before it actually changes. And it's not that important to know when it will happen. I think when it comes down to change, a more effective question is, if you change the code that if you change the code that makes this use case happen, who will possibly be impacted? That's a far more effective question to ask yourself. And does this match with who should be impacted? So only the stakeholders who want the code to change should see the effect of your code changes. Nobody else using the application in different ways should ever notice the change. And a design that allows you to do this is an effective design. Here's a quick example. Imagine that you have two groups of stakeholders or customers or whatever, right? And let's say that one group is from Europe and the other group is from the United States, and they both need the same functionality. And let's make something up. They both need a specific business-related case of tax calculation. Here's a representation of the code that's needed to do this tax calculation. Both groups, both of them, use the exact same code because at this moment, the use case is exactly the same. Great. But all of a sudden, Europe agrees on new regulations. Every once in a while, they do that. The code for this use case needs to be changed. If we change any code in this representation, who is most likely going to be impacted? Well, since both of them are using the same code, which makes sense at this point, then both stakeholder groups can possibly be impacted if we're not careful. But who should be impacted? Well, I would say only the European group of stakeholders or users. In this case, who should be impacted doesn't match with who will be impacted or who could be impacted. And so this means that for this change, we've got some work to do. Now, all the changes that come from stakeholders, you can put them in two categories, two major axes. And there's going to be change in what people want, what people need and what people require. Those are your use cases. I already said that. And people are going to want new functionality, or they don't need any particular functionality anymore, or maybe they just want a different result. And then there's also going to be change in how people want something. How people want or need something that represents variations of a use case, like we just witnessed in my example of the tax calculation. Now, it can be a variation in most of the use case, or it can just be a variation in a part of that use case. Now, you might wonder, how is this helpful? Well, if our goal is to make change easier by isolating change, then we should change along the axis of change. Okay, that's a bit of a weird sentence, but concretely, this means that we should isolate our code based on use cases or features. Prefer to avoid code reuse between use cases, right? Or features. And especially when it comes down to processing code. And what I mean with processing code, it's like the business layer, right? To talk in terms of clean architecture, it's the code in between the input and your domain models and whatnot. That's processing code. And the biggest exception of avoiding code reuse is, of course, your entities or your domain models, right? Because if you have multiple use cases, it's quite normal that they use the same entities or the same domain models, right? And there are other exceptions as well, but in general, prefer to avoid code reuse between use cases. And then when that is done, start isolating the different steps of the use case or the process, because use cases, they're basically processes, right? They're basically input and then some transformations, whatever, some things that need to happen. They are persisted, and then there's some output. Either one of these steps can vary, or all of the steps can vary. But it pays off to separate the different steps of a process or a feature. This can either be a separation by class if the step has some complexity, but it might as well just be a private function or a method or something like that. Isolating code alongside these axes will make your code easier to change, and it will make the effects of change more predictable. And by the way, in my opinion, this is one of the quickest and most effective ways to come up with a decent base design or a base structure for your application. Of course, it will need to be fine-tuned, but it's a great start, and often in the most simplest of cases, this can already be enough, right? So the truth is that change is inevitable. Change will come sooner or later, and we need change, because without change, there's no evolution, there's no progress. Let's take a closer look to evolution. Software is not the only thing that changes, right? Everything changes. The world changes. That means that your stakeholders will change. Maybe their businesses have grown to the next level. Maybe they have expanded. So they are going to need different things. Their needs are going to change. And on the other hand, the company that you work for will also have changed over the years. So your stakeholder composition might look very different, and different people are going to want different things, and probably, or most likely, in different ways. So that means more different stuff and more possible variations. In both cases, it comes down to the fact that the context that we work in is changing. No matter what, our context evolves. And if the context evolves, then the code should be able to evolve along. It should be able to change along. Now, what does this mean in particular for us? It means that what seemed important in your design yesterday is possibly no longer important today, or maybe it's the other way around. What was first a detail is possibly no longer a detail and can become a real part of the design and the evolution and the solution, sorry. So we need to keep this in mind. We need to keep evolution in mind. We cannot stick forever with the same solution. We need to be able to let go for what is important today, for what is important right now. Then the next thing that we should understand is complexity, right? Let's talk about complexity. Let's dig a little bit deeper. When I'm talking about complexity, I am talking about both the complexity of the problem that we're solving and the complexity of the solution that we are offering. And what we want as developers is we want to enable change. And we do that by applying software design techniques and principles and whatnot. But, and this is very important, listen carefully, software design starts to make sense when there is some complexity in the problem that we need to solve. But on the other hand, applying techniques and principles, it tends to add complexity to the solution. But we want to keep the solution simple because we want to be able to change the code and the application rather quickly. So I hope you can feel that there's some tension there. What does this mean? It means that we need to be aware of the design decisions that we take. If the problem that we are solving is quite simple, it doesn't make sense to complicate things with software design. If the problem is straightforward, then the solution needs to be straightforward and simple. You don't need abstractions and design patterns and whatnot for simple problems. It doesn't make sense. A simple problem requires a simple solution. So keep it simple. Now, how do you do this? I have a rather simple but awesome trick, and it's actually really obvious. So when you are going to implement something software design, ask yourself, what will the result be? Does this really improve the ability of my code to change? And you need a good understanding of software design to be able to do this. Now, here's a small anecdote or a small example to highlight what I mean, right? Once upon a time, and actually it's not that long ago, me and my team, we were building something to fetch data from an API. And then we needed to transform that data into something that we know, something that are standard in our company. And then we just need to persist the result. It's a very simple problem, really. And I think almost everybody here has probably done this before. Now, the API had 3 or 4 interesting endpoints, and each endpoint produced XML. Yeah, okay, maybe it's a while ago, right? It produced XML, and it was similar, but not entirely. And the information that we got from those endpoints was related, but not the same. And this is also important to know. During the investigation of the API, our team had seen that some of the endpoints change without prior notice. So on the API side, somebody broke the contract without letting us know. Okay, the first implementation was actually very simple. 4 endpoints to call, 4 use cases to deal with each type of information. This leads to use cases that looked similar, and they had some code that looked the same, but some details here and there were different. The solution, however, did not pass code review, and the reason was code duplication. What followed was a pair programming session that took a couple of hours, where an abstraction over another abstraction took care of processing of all four endpoints. The second abstraction and some extra code was necessary to make it all work, right? Without the second abstraction, it didn't work. The result, it had removed all lines of code that were duplicated. And it looked very elegant as well. I have to say that it looked elegant. However, the abstraction over the other abstraction made the code quite hard to understand. So in this case, dry, don't repeat yourself, was applied, but did it really make sense, or did it really make the code easier to change in the end? No, not really. A couple of people spent some hours first discussing and then implementing a solution that was hard to follow and hard to understand. And that's not all. The endpoints change independently from each other. We've seen that. We saw that already while we were investigating the API. So when one endpoint changes, and there's a real chance that it will, right? How long will it take to implement a change? There was quite some time wasted on a solution that is reasonably complex, and there will be some time spent in the future figuring out how to make changes without breaking the application. The problem was rather simple. The solution somehow got complex. That is just not effective. Now, there's more to understand about complexity. Now, complexity of the problem, right? I'm talking about the problem. What makes a problem complex? Well, the first part is the domain, right? The domain is also part of your context. If your domain is complex, then obviously the problem will be complex as well. But the second part is the more interesting part. The second part of problem complexity is your stakeholders. And then in particular, the composition of your stakeholders. Why is that? I've actually already mentioned it. It's because stakeholders give us reasons for change, right? The more stakeholders you have, the more reasons for change you will have. And also the more diversity you will have in your stakeholder group, the more variations you will have and what these people want and what they need and how they want it. And rest assured, stakeholders will ask for changes, and you will have to enable those changes, even though the problem gets more and more complex. Stakeholders fuel the tension between complexity and enabling change. And they do that, on the one hand, because they add more complexity to the problem, right? But on the other hand, they fuel this tension because they still need us to deliver. They still need us to enable change in the solution. And this tension that we have will also produce trade-offs. All right. We've covered a lot of ground so far, right? Let's have a small summarization of what we've talked about already. At the center of everything, in my opinion, is understanding. That's what we need to be effective again, especially, right? Understanding. We developers, we need to go back to understanding. And understanding of what software design is, understanding of what the goal is, so that we understand better why we are doing what we are doing. We also need to understand context. We need to acknowledge context, recognize it. And then, it's only by understanding our context that we are able to make decent trade-offs. We also need to understand change and where change is coming from, right? We need to accept evolution for what it is and let go of previous solutions. And we also need to understand complexity and take it into account when we make decisions. In my experience, very few people understand this. And so, time as a resource, if we look at time as a resource, it's a precious resource. It's not only precious for us. Our time matters for me, it matters for you, but time will matter for your employer as well, right? Time will matter for the people whom you're building the solution for. So it matters for your stakeholders. In the end, it's actually all about time and money. And so there's a harsh truth in our industry. The people who control the money, like your stakeholders and your employers, they will favor quick solutions because time is money. And they will favor people who deliver quick solutions. And I know this from personal experience. It's a bad experience, really. And I'm pretty sure that I'm not the only one who has experienced this. And we as a community, an industry, we know better. We know that quick and dirty is also costly and that we should do better. So we should be aiming for as good as possible and as quick as possible. And we need effective decision making for that. So decision making is the most difficult part in software design. But we need good decision making to be effective. How can we make better decisions? I think it comes down to just two questions. Should I spend time on implementing software design principles and patterns right now, as the problem is? And the second question is, am I actually building a better solution, yes or no? And those are the kind of questions that we need to ask in order to stop pointless discussions about semantics of single responsibility or clean architecture or whatever. Question your decisions and see if they hold up to the cause. And the concepts that we've just discussed, they will give you the necessary information to answer those questions. Understanding the goal of software design and understanding complexity will guide you with when to apply more software design. Understanding change and understanding context should guide your decisions for building better solutions. What do people really need? Who is going to be impacted by change? Is that okay? Right. So that is the first part of being effective. But what else do we need? I mean, it cannot only be these simple concepts, right? What else do we need to be effective in software design? And now I think is the right time to mention, certain design concepts. What I think is important to be really effective in software design is just a deep understanding of a handful of concepts. Those concepts are separation of concerns, high cohesion, low coupling, abstraction, and polymorphism. I guess you're probably a bit surprised by how short that list really is, but they are the foundations on which all other principles and patterns are built upon. And so I think we still have some time. Correct me if I'm wrong, we still have 10 minutes. I would like to go over them rather quickly, though, if that's okay. If it's not okay, you can interrupt me here. Okay, let's quickly do this. So, separation of concerns. The whole idea of software design is to structure code into isolated units, which each can do something meaningful and they cooperate somehow. So isolation is central. We want to isolate functionality so that change to that functionality can be isolated. To put it overly simple, what we want is to think modular. And separation of concerns is a no-brainer for that. In my experience, separation of concerns is not that well understood, like so many other things, actually. Separation of concerns, what is it really? It's a concept invented by Edgar Dijkstra. He was a Dutch mathematician and one of the earlier thinkers of our industry, actually. And he came up with separation of concerns. And what he originally came up with is that one should just focus on only one aspect of a subject at a time. That's it. That's separation of concerns, nothing more. Originally, there was not even a link to software design. So it's not that hard to make the link with software design or to see the link with isolation, what we desire in our modular code. However, because it's so easy to see the link, I think separation of concerns can be interpreted in many ways in the context of software and designing software. And that is, in my opinion, the biggest trap where people fall into. Now, in the context of being effective with software design, I see separation of concerns as a design guideline, which states that we should separate the problem into different sections or subproblems so that we can focus on the implementation of each one of those, and also that we can focus on the evolution of each one of them. And I'm not only talking about having different layers in your code, layering, and it comes from clean architecture, and it seems to be the most used context for separation of concerns. When it comes to separation of concerns, also think different use cases that we keep in isolation. Think about different domains, think different microservices. All of that is separation of concerns. It just depends on the aspect you want to focus on. Now, in order to have an effective software design, we need separation to enable change. The problem with separation of concerns is that it doesn't really tell us how to separate. And this is where we can benefit from high cohesion and low coupling. Let's talk about cohesion and coupling quickly. For those who don't know, let's just quickly go over these two concepts. Both cohesion and coupling, they are metrics. They try to put a number on something. Cohesion is a metric that indicates how much elements belong to each other. And coupling is a metric that tries to put a number on the degree of dependency. In other words, it's about how elements depend on each other. Now, it's quite hard to quantify these things, to put an actual number on that, right? And I don't want to go too deep into semantics here, right? The thing is, this is the base definition of both of these concepts, and I don't find it very useful yet. It doesn't explain why we want cohesion, but we don't want coupling. So you see, both coupling and cohesion, they are concepts about code dependencies. They are concepts about relationships between code units. Both cohesion and coupling, they insinuate a form of connaissance. Now, for those unfamiliar with the term of connaissance, I will quickly explain it. Two components or two code elements are connaissant if a change to one element would force a change to another in order to keep the application correct. This term was invented by Meir Page-Jones, and basically, this is what's happening with both cohesion and coupling. If one of the cohesive or coupled elements is changing, it will most likely force change in other elements. This is a consequence of defining dependencies or having relationships. So what's the difference? Why do we want lots of cohesion, but we don't want lots of coupling? Well, here it is. Cohesion is the relationship or the dependency between code elements from which we want them to change together. We are okay if they impact each other because they belong together, right? They mean something together. They accomplish a goal or something like that. The impact that they have on each other is to be expected. That is a better understanding of cohesion. And it's the other way around with coupling. I see coupling as a relationship between code elements that do not belong together. The impact that they have on each other is not desired. That's a big difference. And I think that's a bit more useful as well. So how is this helping us to be effective in software design? How does this help us to decide what to separate and what to group together? It's fairly simple, actually. We want to group together those elements that we expect to change together, and we want to separate elements that we don't want to change together. This is, in short, really short, what cohesion and coupling actually means. I could go into more detail, but it's out of scope for this talk, and we're going to go over time otherwise. Okay, next up, abstraction. I think we also need a good understanding of abstraction to be effective in software design. There are a few ways that you can interpret abstraction in software design, but let's just stick to the general meaning. An abstraction is a generalization. It's a representation of something where irrelevant details have been removed. It's what stays true when details change. That's basically a quote from Uncle Bob, and I really like this quote. It is what is left behind when irrelevant details are removed. Abstraction allows us to remove details so that we can focus on what is important. Abstraction can have different meanings in the world of software. For instance, an interface is an abstraction, but let's just keep the scope to software design. Here's a quick example of what abstraction really is. Everybody knows that this is ice cream. Well, actually it's an image of ice cream. So what if I started removing some details? For example, the color and the texture of the cone, right? What if I remove the taste and the color of the ice cream itself? What we have left is a silhouette of ice cream. We still recognize that this represents ice cream, but the details that are irrelevant to identifying ice cream, they have been removed. The silhouette is an abstraction. Abstraction is important for being effective. Now, how is that possible? It's because abstraction allows us to remove details that are not relevant in our current context so that we can focus on the details that are important. And this is a throwback to separation of concerns. For example, if we want to only focus on the taste, then nobody cares about the cone, right? So we can remove the cone that holds the ice. We can abstract that away. If we can remove details and still understand the meaning of the abstraction, we can also change certain details without changing the meaning of the abstraction, right? What I did here was I changed the flavors of ice cream. This concept of also being able to change certain details without losing the meaning of the abstraction is extremely powerful. How ice cream tastes is just a detail. We can change that without changing the meaning of the abstraction, right? We're still talking about ice cream. I just want to emphasize that you can apply this in programming as well. And I would even say that programming is abstracting, and you benefit tremendously if you understand the power of abstraction while designing software. Now, the last concept that I want to talk about, and that I also think is very important, is polymorphism, right? I think everybody has heard about it. Now, polymorphism is a bit the odd duck in the row of concepts. And I wasn't really sure if I should add it or not, because software design should be independent of the language that you use for your solution. And polymorphism, it's a bit language specific. It's debatable. It's language specific in the sense that not all languages support polymorphism. But I put it in here because together with abstraction, polymorphism forms the base of so many behavioral design patterns and so many principles. It's actually a really important concept. So we all know that polymorphism means having many forms. And in the context of software, polymorphism is code units that have different forms while sharing the same interface. Something like this. Now, the definition that you see here is based on a quote by a person named Steve Guidetti. And what you see here is how it works, right? So you have an interface and you have different forms that use the same interface. I just want to mention that I stole this. Here's the name from a person, Steve Guidetti. I'm not sure if I'm pronouncing it correctly, but he wrote a book about polymorphism in PHP. Just mentioning this. Also, when I say interface, I'm not talking about the keyword interface. The interface here is just the means to interact with the code unit, as in the list of public functions or methods, right? Now, by just having the ability to have multiple forms, that's not enough. Polymorphism is also the ability to present those different forms of code with the same interface. It's the ability to present these variations of the abstraction. It's not enough for code units to share an interface. You also need to be able to do something with it. In other words, we need a mechanism of some sort that will figure out which form or which implementation should either be executed or loaded when using polymorphism. Now, in Java, this mechanism is called dynamic dispatch, just for your information. This is basically what allows us to change implementations, right? And that's the superpower of polymorphism. So, in my opinion, being able to exploit polymorphism is being effective with software design. All right. Every once in a while, I hear the following. Hey, Nicholas, what you are saying, we already know this. What you talk about is so trivial. It's so easy. It's not something new. And I get it. And I know this. This is not something new. I'm not reinventing the wheel or or I'm not coming up with something mind-blowing. But to those people that say we've already heard this, I say to them, can you then please start applying it? There's a huge difference between knowing the path and actually walking the path. And this is exactly the step that we need to take back. Learn the trivial stuff and the base concepts. Be like Bruce Lee and practice these 10,000 times, and then go back for the more advanced things. Thank you very much. This was my talk.
Wow, it was amazing talk. Thank you so much for this one. We have quite some questions and topics for discussion, so I remove your slides for now. Maybe we will need them later again.
Sure.
So let's start with this one. How do you usually approach delivering a very similar feature to two different stakeholders? How do you decide between code reusability and triple effects for future divergent changes? Actually, we also got an example to this one. Maybe I can show it to you first.
Sure.
An example can be a use case that handles placing an order for a given customer. You have validation that can be the same for two different business units. Still, they may diverge in the future.
What you're basically asking is, what is the best way or the proper way to apply don't repeat yourself? And I have a very simple rule for that. What I do is I ask myself the question, if I have two pieces of code that are similar, if I have to change one of them, do I also need to change the other one in order to keep the application correct? If that's the case, then you have duplication, and then you should go for reuse. You should go for abstracting it. If it's not the case, if one can diverge and the other one doesn't need changes, then you have to separate them. You might have colleagues say, hey, you have code duplication and whatnot, but in my experience, you have to separate, because it will bite you in the butt later on. I can say butt, right? Okay.
You can say. So I should say, yeah, I share same experience as you do. So actually, we had quite some discussions on this one. It was before we got the example. Wolfgang said that maybe with different read view models, separate read and write side. What do you guys think of this one?
Well, discussions like these, in my opinion, are most useful when you have the full context. I mean, having different read and view models can absolutely be a solution for this problem, but it doesn't have to be. It depends a bit on the context that you're working in, right? Are you using read and view models when I say different read and view models, I immediately think CQRS. Are we using CQRS or not? If we're not using CQRS, are there other ways where we can do this, where we can solve this? But for sure, if you're already using it and if it's in your context, if it enables that, then why not, right? The problem can also be, and this is what I often see, by the way. Usually, when there is real duplication, it's in the models, it's in the representations of real knowledge, something that represents the domain or domain problems. And when you think you have duplication, but it's not really duplication because it might diverge, it's usually in the code in the processing code, right? How should I say this? The body of the use case, where information is passed from one point to another point and then transformed in some way. And it's usually a variation in the transformation that is going to diverge in the future. I'm not sure if that's enough information or if that answers the question or the discussion, or if you guys have something to say about it.
Do you have any?
Yeah, I mean, it makes sense. I mean, what I have seen is that much of the code is actually the same, but for example, you have one user group that gets the data from one backend and the other user group gets it from another backend. So you will have this if-else in code, and then basically you already know, okay, this is actually should be separated.
Yeah.
So it looks in the beginning, it looks like the same, but once you start implement, and especially if you have different stakeholder groups. So if you have one group that's like, yeah, we want the same, but, and after a while they come up with, yeah, but we want actually the same, but this part should be a little bit different, then you end up with this if else, if else, if else in code.
You don't want that, those if
No.
else.
No,
That's
definitely we don't. So we could keep following this discussion. So this one was after the example. He half answered, but in his last name, avoid abstraction if it doesn't fit. It's better option to have some code duplication in this case.
Yeah, this reminds me of probably a famous quote by Sandy Metz, who said, "It's far more cheap. Duplication is far more cheaper than the wrong abstraction," and that was a game changer for me. I don't know if you heard of it, but it was a game changer.
Makes sense. Okay. So I was separating the entire class or use case or by steps.
Okay. I see. Also, this answer, I'm sorry, is again out of context, right? But my default go-to is whenever I see a variation in even a part of a use case, I tend to think that it's okay to quote unquote duplicate the use case. I mean, in my experience, I've had the case where we had use cases that were very similar, and people, it's the code reuse myth, right? They think that they are going to save time by reusing things or by trying to keep everything as reusable as possible, and so they go out of their way to just separate small parts of code. And sometimes it works, and if it works, fine, I'm fine with it. I'm not debating it. But usually it doesn't work. They go out of their way and actually make everything a bit more complex. But again, it's my default. But if I see that, just saying something, copying 20 classes for just a small variation in a use case, I mean, that's overkill, right? Yeah, it depends. It depends. But I tend to duplicate the use case. If it makes sense, I tend to duplicate that. That answers the question.
Mm-hmm. Well, I guess this was the question. And I guess it's again depending on the context, as you explained us before.
Yeah. Well, I do realize that this is a bit of an easy answer, right? Yeah, it depends on the context. You can win almost any discussion with that. But it is true, right? It's the same with these. I don't want to offend anybody, but with these horrible examples of explaining solid, and they just give you two pieces of code, and then they say, yeah, it's violating single responsibility. Yeah, but where's the context? I don't know if it's violating anything. I mean, and yeah. So if people would say, yeah, it's easy to say it depends on the context, I understand, and you're absolutely right. But on the other hand, I think you can only have a very valuable discussion when you have all parts of the context of the situation, right?
Yeah, I guess we all totally agree with this one.
Okay.
So let's move to the next question. It has two parts. Most of the time, we have good architectural designs done initially, but down the line during the development, the architecture performance with implementation seems to be lost. How to make sure but we don't lose the conformance from the design to implementation? And of course, thanks, Nicholas, for your insightful session.
You're welcome. I'm happy you liked it. Also here, what I would say to this, for me, this feels a bit like we're having discussions. It happens a lot in almost every team that I've been in. We work on some part of the code. There's some decisions that need to be taken, right? And somebody thinks that the conformance of the design is going to be violated. It's going to change, and it's not going to be okay anymore. And my rule of thumb is I'm actually pretty fine with most solutions as long as they still enable change. So one of the first questions that I'm going to ask is, your solution, whatever it is, can I read it? Is it understandable? Is it not too complex? Check. And if this thing change, and most of the time change will be in a particular use case, it will be variations. If there is a variation of this whatever, who is going to be impacted, right? What is the impact of that change? Is it still easy to change? Yes. Then I don't care if you. People are probably gonna hate me, but I don't really care if you don't make that distinction between all of those different layers anymore, or whatever. I've had countless discussions with people saying, hey, this class should be in the infrastructure level, and this class should be in some business whatever layer. And they're probably right. But all I care about is if this thing changes, right? If somebody comes along and says, hey, we want this and this detail changed, and we want it rather quickly, can we still do it? Yes or no? And that's the big part. And of course, it's important to the layering and whatnot, to keep an eye on it. But yeah, that rule of thumb, how easy is it to change? All the rest, in big parts, taking shortcuts here, all the rest is quite okay. I don't like architectures, for example, clean architecture or hexagonal architecture. For sure, they have their importance, but to me, they're not dogmatic, right? And yeah, I'm not dogmatic about it. I want to be as effective and pragmatic about the code that I create, so that I can deliver value as good as possible and as fast as possible. And debating semantics, yeah, exactly. I totally agree with that. Debating semantics just doesn't help us. That doesn't, by the way, the other side is also true. That doesn't mean that we cannot have a discussion about it, right? But not for hours. And then after the discussion, please, if it's easy to change, let's not go into the code again and make abstractions upon abstractions and change everything again. That's the kind of thing that I mean. And now that I think of it, there's also one other solution that you can do to maintain a bit of rules in your architecture. You have libraries for that. Architectural archetype or something like that in Java. I'm not sure. You can look it up. I'm sorry?
ArcUnit is the name of the library to check layers.
Exactly. And I mean, with those, you can, without debating, you can just conform a bit, of put some conformity in at least the layers. You can do many things with that. I've used it. I think I don't know. I was going to put a number of years on it, but a long time ago, something that looked similar like that. We used it. We liked it. Then I changed companies, and now we're not using it anymore.
I guess for this one, you have to have an agreement in the team what architecture patterns you're using and how strict you are with those patterns, right?
Exactly. However, and this is from my personal experience. I mean, I'm only a guy from Belgium with only 15 years of experience. I mean, in the grand scheme of things, it means nothing, right? And so what I'm saying here is from my own perspective. And I do find that people, the more senior they are, the more dogmatic they tend to get. And I like your suggestion of agreeing, but I haven't seen it happen a lot. in my small reference of experience.
How about you guys? Did you see teams agreeing on patterns?
Well, for that discussion, it's just like, I mean, if you say, well, let's take shortcuts, I mean, it's a very deliberate decision. And what I see sometimes is that actually people that want to take the decision, like, yeah, let's skip this abstraction, let's don't do this, they actually don't know a better design or another design. So if you are very if you're very experienced in actually applying clean architecture, hexagonal architecture, whatever, and you know how to refactor, you know how to produce a good code, yes, then you can also discuss and say, well, let's not do it here because you understand the consequences of your decision. But I see many people that just say, well, that's not pragmatic, let's not do this, let's hack this part of the code, and then after a little while you will be in spaghetti code hell. So that's a little bit, I mean, if you said yes, I agree. We should not be dogmatic, but this can be used as an excuse to actually do bad design.
Yeah, I agree with that. That's also true.
An answer from Wolfgang.
That actually reminds me of a post I've seen on LinkedIn about this specific curve, which has most people probably have seen it. Yeah. And the beginning of the curve, when the complexity goes up, because every design pattern you see is a hammer and every problem is the nail, right? And in doing so, you make everything a bit more complex, and with more experience, you see that. But I agree with you, Oliver. It's the other side is also true. It cannot be an excuse for not designing anymore.
Another point I can agree that you mentioned that the older is someone or a longer experience he or she has, then it's more difficult to change him or convince him. So more dogmatic he or she is. And I also met with such people, and what I realized that I really appreciate working with junior developers because they are not dogmatic of anything. They are open mind. They have this open mindedness. They have this beginner's mindset, and I think that's what we all can learn from juniors, that they really have this beginner mindset. They are asking the whys, asking all the really great and simple or deep questions, and they are open to new things. And as you said, some seniors are really close-minded and know only this works, only this is the one because they have a long experience. So we can learn from juniors a lot in that regard.
I actually used to be one of those developers. I was very dogmatic back in the days. Yeah. Are there more questions? Let's not go.
There are a lot of more questions, but let's move to the next one. Also, I'm very curious what changed, but maybe I will ask it later. Okay, let's move to this one. Which one is most costly? Starting with the wrong architecture and changing it, or stay on the wrong architecture and do bug fix?
Yeah, that's a hard one. I think starting with the wrong architecture, I mean, what's the wrong architecture, right? How do you define the wrong architecture? I wouldn't like my mindset right now how I am as a developer right now. I would fight fiercely if I see an architecture which doesn't enable change. I would absolutely raise that and try not to start with it in that way. If I see it, it means that we did something wrong. I'm not saying that we should do upfront design for a very long time, but if you start with the wrong architecture, you might think a little bit more before you actually start. And then wrong architecture and then doing bug fixes. that can also be very, I mean, if you start wrong right off the bat, I think that will still in the long term be the most costly. Try to do it good from the start. I mean, yeah, it's there's no easy answer here. There's people talking about what's it called, the strangler pattern or something like that. Where they try to keep alive architectures, actually just code bases, try to keep them alive, try to have them deliver value for their customers and stakeholders for as long as possible while changing, actually while making important changes possible. Is it costly? Yeah, I guess it is, but it depends on how many bugs that there actually are. I think the most costly thing about a wrong architecture that you're trying to fix, either way, is it by strangling or bug fixes or whatever, is the time it takes to actually change something. I've been in countless situations where, stakeholders, they have their businesses and, time is money, right? Everything is urgent, and they yell and they do and whatever. It feels nice if you can deliver quite quickly because your architecture is nice. But in a lot of times, yeah, it was hard. It took a lot of time, and yeah, you had unhappy customers, and yeah, I mean, either way, it's going to cost a lot, and I don't think it's easy to say which one will cost the most. I don't know what you guys think about this. Otherwise, I think I would keep on blabbing on for 20 minutes. What were your ideas?
In my opinion, is that yeah, I mean, refactoring a messy architecture, might cost too much, but not refactoring it will cost more in the long term, because if you don't refactor it, it will slow you down forever, basically, right?
Yeah.
It will slow you down as long as you have it. But if you spend the time and refactor it, then of course you can save some time. But you are totally right with the point that everything is so urgent. They want to have the feature delivered by tomorrow, and it's difficult to convince the management that, okay, we need to spend a few days or even weeks to refactoring a real big messy architecture. So really finding the balance is yeah, it can be challenging.
We actually have an answer from Urs. The architecture needs to change anyway at some point, so better to make it changeable earlier than later.
Exactly. Also, I've had some discussions. Those were quite interesting. They're specifically about microservices, and there are people saying, yeah, microservices should be easy to completely rewrite. So you shouldn't care about software design when you're creating microservices. They're only 4 classes big, right? And then you just whoop and rewrite them. However, in my experience, yeah, there's I haven't seen many microservices that are only 4 classes big, right? And usually they contain these details and these small, I don't know, small things, small variations, small use cases, even that a particular group of stakeholders like, and it's not really that visible. And so people who are ordered to just wipe away the microservice and rewrite it, and I'm saying microservice, but sometimes it's just monoliths as well, you miss those tiny details. And so if the question would it be cheaper to just rewrite it? I say no. From experience, definitely no, because you are going to miss small points, small details that people rely on, but you just didn't know of as a developer.
And those people may not even be around anymore. So even if you try to recreate the knowledge, nobody could tell you.
Exactly.
And it's so hard. Okay, let's move to the next topic since we don't have much time left. What are the biggest design mistakes you have seen?
Well, the biggest design mistakes I have seen, incidentally, all have to do with applying dry. It's where people want to reuse stuff. I'm just saying stuff. I'm not going to call it classes or functions. It's just stuff. And they make these abstractions in the name of reuse and not repeating themselves. And yeah, I mean, and that's the thing. Usually it looks very elegant, and you look at the code and you're amazed that, wow, this seems so smart and so good and so awesome, and wow, the person who created this must be so smart, and you don't dare to touch it. And then change comes along, right? And you look at it and then you're like, how am I going to change this? And sometimes people don't dare to touch it because, wow, the solution is so cool, and what am I going to do? And what happens is yet another pair of if-else statements, or in some cases, some more dependency injection, making constructors bigger and adding some more functionality or whatnot. Those are the biggest design mistakes that I've seen on a code level. I don't even want to get started on an architectural level. And there might be people watching, so let's keep it general.
Okay, I guess we can discuss it offline.
Sure.
So the next one. So Nicholas, I agree with your thoughts, but how to convince interview during interview?
My God. Yes. I don't know how to answer that. I have been in so many interviews, even interviews where we were coding along, and I just failed the interview, and there's that. I don't know how to answer that question. This is just it's not manipulating people. It's conveying people that you are right. But do you really have to do that, right? What you expect of your colleagues is that these are also big words, but that they also understand. And a couple of years ago, I guess 2 years, I was in the situation, I was in dire need of a new job, and I flunked almost every interview because we had these huge discussions on design. And I was like, okay, in the end, maybe it's better that I didn't start it there. Maybe it would just be all meaningless discussions.
Yeah, exactly, because we are looking for a good match. We don't sell another version of ourselves.
Exactly.
So
Exactly.
I can make a guess that we all share the same experience on this one. So, and then we have some inputs of Wolfgang. Coupling and cohesion. Vlad Kananov is writing a book about that topic right now. We are waiting for this book. Actually, Vlad will be a speaker at Tech Excellence in a couple of months, so don't miss this session.
Oh, I will definitely be there. Yes, absolutely. I'm very interested. Also, and I want to add to that, the things that I've said today are, ideas and experiences and whatnot, and they come from within me. That doesn't mean that they are the absolute truth, right? It doesn't mean because I defined coupling and cohesion in a slightly different way that this is the only way. And this is also something I want to give to people. Be just open-minded and take in whatever. Be like Bruce Lee. That's also something I really like Bruce Lee, and he said, something along the lines of taking all in the information that you can, but you are the one that has to experiment with it and then decide what is useful and what is not useful. Be your own guru.
That's great. So another input of Wolfgang, isolate change bounded context is a useful concept here too, in my opinion.
Exactly. When I mentioned separation of concerns, bounded context on a bit of a higher level is an excellent example of that.
Yeah, absolutely. So another one, because I can, will destroy this planet. It's a good one.
Yes, I agree.
So, and maybe in the end, for last minute, could you give some books recommendations?
Purely software design. I would still go with it's I would still go with Clean Architecture by Uncle Bob. I mean, it's highly debatable. It's highly debated already. but it gives you impressions that are very useful. And on the top of my mind, there was also a book called can I look it up? Do I have time to look it up? What the title is?
Yeah, maybe, or you
Sure.
even can write a comment on LinkedIn later.
Okay.
You like.
It was Modern Software Architecture or something like that by I forgot the authors.
Dave Farley.
Dave Farley, also another. Yeah, I wasn't talking about Dave Farley, but that one as well. Yeah, I can look it up. I can look it up. Yeah, Dave Farley, obviously. Yes. Anything, his videos as well. Not only books, his videos as well. Absolutely.
So if you like, you could, for example, add some comments on LinkedIn later when we upload the video.
Yeah.
There's a list.
Or people can follow me and ask me directly these questions as well. It's fine. I usually answer within the week.
This is great. So we need to wrap up. Nicholas, I was very happy you were here today with your great presentation. We have also a lot of thanks in the comments. You can read it later. And you guys stay with us. We will bring another great speakers. And don't forget, learn how to deliver quality software faster. Thank you very much and have a great evening.
Thank you for having me.